Welcome to the Climate Map podcast. The Climate Map, an initiative founded by Covalence Global, outlines the complexities of climate change on a streamlined, action-oriented mind map. This podcast is an archive for our research, highlighting conversations with entrepreneurs, scientists, policymakers, and designers. You can learn more about the Climate Map at theclimatemap.org. Today we're excited to welcome Dr. Moet Ashfaq, a scientist for the Computing and Computational Science Directorate at ORNL. In the episode, we discuss the role of scientific modeling in Pakistan flooding. Tell us a little bit about yourself. Where are you from, and what is your journey in computational climate science?
I was born in Kashmir. That's an area between India and Pakistan. So my early education, early college was in Kashmir. And then I did graduate studies in Pakistan in two cities, Lahore and Islamabad. My background originally was in math and physics. I have a physics master's and master of philosophy in computational physics. That's a very different background than what I'm currently doing. So when I finished my master's of philosophy in physics, I was looking for a PhD position somewhere in the US in material science. But at the same time, I was looking for some like short-term opportunities to work. And at that time, a new center was established in Pakistan, Islamabad. It's called Global Change Impact Studies Center. So I applied there. They were looking for people with computational science background. So I landed the job there. The center was focused on climate change. So that was the first exposure to climate science for me. And after I worked there a little bit, I started liking it, and I realized that maybe that's the career that I want to pursue. So after doing work there for a couple of years, I looked for a PhD position again in the US, but this time in atmospheric science. So I came to US and did PhD, and then after that, that's my first job that I'm currently doing. So that's how I ended up being a climate scientist, but I started my career as a physicist.
Awesome. Can you please provide a high-level explanation of what global climate models are and why they're important for our world?
So global climate models are physical tools. They are the most sophisticated tools to understand our system in the past, present, and the future. We use them for weather forecasting, for subseasonal, seasonal prediction, and also these are the same models that we use to project how climate may change if the greenhouse gas concentration keeps on increasing in the atmosphere. So these models are very complex and they require supercomputers. Not everyone can run them. You know, the IPCC reports are based on like about 50 of these models, which are developed across the globe. So I'll say these are the backbone of all we know today about our system. These are the models that we heavily rely on and knowing what may happen tomorrow, in a couple of weeks, in month, season, and in the longer term timescales. Now, what we did over South Africa is rather than using climate models, there's another approach that we call empirical modeling, which is more mathematical. It does not represent our system in the physical way, but what it does that based on our understanding that how, say, precipitation, if you want to know over a region, how precipitation is being generated, what mechanisms affect precipitation generation. If we understand those mechanisms, and then we can further go in more in-depth understanding and try to understand when there is more than normal precipitation or less than normal precipitation, what are the drivers of that precipitation variability. So once we understand those kind of drivers, we can use that information to build empirical models. So these are very, very simple mathematical models which are built upon this knowledge. Sometimes these models are able to provide better like understanding than the physical climate models. And the reason for that is the physical climate models have their own issues. Sometimes they don't work good over certain regions. So South Africa is one of those regions where we found that the simple empirical model that we developed based on our understanding of the climate characteristics of that region outperforms physical models. And we compared it with the two physical models that provide seasonal forecasting. So we did seasonal prediction this winter as a test case, which is winter in the northern hemisphere, but it's the summer in the southern Africa. We found that our prediction using our simple empirical model could outperform the two leading season forecasting systems. One is in the Europe and one is in the US.
Thank you for making that distinction between empirical models and climate models. What's the difference between statistical downscaling and dynamic downscaling, and how do they affect global climate models?
Now, first we need to understand what is downscaling. There's climate models that are used for future climate projections. As I mentioned earlier, they are computationally very expensive. They often require supercomputers to run. Due to that, most of these models run at a resolution which is quite coarse, it's 100 and 150 kilometer. So at that resolution, we can tell that how a regional climate may change, say over southeastern US, how it may change in next coming years, decades. But say if you want to understand climate change impacts over much smaller and local regions, say like a city or community or state level, that 100, 150 kilometer resolution is not sufficient. So for that, we do downscaling, which basically we refine the climate change signal in these global climate models. So there are two approaches. One is called statistical downscaling, another is dynamical downscaling. Now, statistical downscaling is just like empirical modeling. When we do that, we develop a mathematical relationship between high resolution observations and global model simulations. And based on that, we downscale, refine those simulations at higher resolution. Now, there are some drawbacks of statistical downscaling. One, that it depends on the relationships that it learns in the historical period. And we know that these relationships may not remain stationary. In the future, those may change, but that's not the case in the statistical downscaling. It considers them as stationary relationships. And other than that is that if statistical downscaling can correct the errors in the distribution of temperature and precipitation, if those models have those, but it would not be able to correct the processes in the models that generated the errors in the precipitation distribution. So it doesn't have that ability. On the other side, dynamical downscaling is just like running a climate model again, but at a limited area or smaller area. That's why we call them limited area models or regional climate models. So those models use boundary forcings from the global model simulations. And because they're running over a smaller region, they're computationally relatively less expensive. And so we can run them at high resolutions. But the challenge is that these are physical models. These are not perfect. They may still have errors in them. And again, because when we run them at high resolution, they may also have computational costs. So not everyone would be able to run regional climate models. Compared to that statistical downscaling, anyone can do that. So both approaches have their own benefits and limitations, and depends on the kind of science question you're addressing. You can make your honest and scientific judgment that which way is the best to go if you want to do climate change impacts over a region.
So, when we're looking at Pakistan, do you incorporate downscaling into that region? And if so, do you choose to use statistical or dynamic?
So in our research, we have done multiple times downscalings over South Asia as a whole, not on Pakistan, but South Asia as a whole. And we have done dynamical downscaling. We have not done statistical downscaling. And one of the major reasons for not doing statistical downscaling over that region is that statistical downscaling heavily depends on observations, good observations. So, and we don't have good observations over South Asia. This is one of the challenges that we have with South Asia, is that there's not good density and network of ground stations and observations, especially over Pakistan. And lack of that ground truth, statistical downscaling has challenges. So we have done dynamical downscaling over South Asia multiple times. And the last time we did that, it's also became part of the IPCC assessment report. So one of the chapters in IPCC assessment is regional climate change, and the data that we produced was part of that effort that produced that chapter.
Wow, that's very impressive. Focusing more on Pakistan, I was reading about how you discussed that the combination of multiple forcings is really what produces both extreme monsoons and also the frequency of excessive rains in Pakistan's western margins. Can you sort of elaborate on that and why Pakistan is facing such extreme weather lately?
Well, yes, it's true that at the turn of the 21st century, Pakistan has experienced more extremes. At the start of the 21st century, we had a very exceptional drought that lasted several years. And then in 2010, we had strong flooding, and in 2022, we had exceptional flooding. So we definitely have more both kinds of extremes, wet and dry. So in our research, we tried to understand what is driving this increased variability of precipitation. Now, note that floods and droughts are common over that region. It's not something that is new. If you go back in time, region has always experienced floods and drought with some like breaks. So we understood that there is definitely a role of natural variability because these things have happened in past. So we wanted to understand how much a role climate change has and how much a role natural variability has in it. So based on our investigation, what we found that there are multiple drivers of precipitation variability over Pakistan. And what has interestingly happened over the last 20, 25 years is that these multiple drivers are co-occurring. So you know that if there is one driver that can cause extreme, if there's another driver that also is present, then you can have compounding impact, right? So what we found that over the last couple of decades, these multiple drivers are co-occurring, and because of their co-occurrence, they have a compounding impact that is causing either extreme flooding or extreme droughts in the region.
Definitely. So, why can't we necessarily relate the cause of Pakistan's monsoons to climate change?
The thing is, we know that there's a common perception and common understanding that the recent extremes in Pakistan is because of climate change, which is true in one sense and is may not be true in another sense. Well, what we have tried to convey is that we should not jump directly to attributing everything to climate change. Yes, there is an increase in extremes. We wanted to understand the drivers. And what we did that we removed the trends from precipitation and temperature because we know those trends are driven by climate change, then try to investigate precipitation variability. And we found that like more than 70% of precipitation variability over Pakistan in the last 2 decades can be explained just based on natural forcings. Now, what are natural forcings? These are anomalies in sea surface temperatures in different oceanic basins. Is maybe the atmospheric modes, like jet stream patterns or wave activity in the atmosphere, which naturally occur. So we could explain just by using these natural forcing that up to more than 70% of precipitation variability just based on those factors. But as I mentioned earlier, that most of these forcings, oceanic, atmospheric, are co-occurring. Now, this co-occurrence is what is causing the compounding impact in these extreme flooding and drought events. And we think that while the causes of these extremes are natural, their co-occurrence may be because of climate change. Well, so what I'm trying to convey is that the direct effect is coming from natural forcings, but the climate change is indirectly maybe contributing to these extremes just by causing them to co-occur. There's another factor that we know that because of the warmer temperatures, there's more evapotranspiration, and more evapotranspiration means that if the same weather system 20 years earlier creates X amount of precipitation, that weather system today may be able to produce more because there's more moisture in the atmosphere if there are warmer temperatures. So that's another indirect effect of climate change. So the point I'm trying to make is that based on our understanding and research over that region, what we found that natural variability is the direct cause of flooding and droughts in Pakistan and its increased variability. But the way these things are occurring and have occurred in recent past, that may be because of climate change. So climate change is definitely has indirect role, but may not have a direct role in causing these extremes.
Thank you so much for highlighting that nuance, how climate change may contribute to that co-occurrence, but the direct relationship are those natural forcings. In your articles, I think you also emphasize that we need to improve subseasonal variation representation in order to better predict extreme South Asian monsoons. So, what type of scientific breakthrough is necessary for this to happen?
Well, so again, coming back to this extremes over Pakistan, what we found that there are 5 different drivers. 3 of them are oceanic, which means they're related with the sea surface temperature anomalies, but 2 of them are atmospheric variability, which are related with the jet stream anomalies and at other wave patterns in the atmosphere. Now, whenever we have a sea surface temperature anomaly, that tends to persist for a longer time. There's the most prominent example is ENSO. ENSO is a sea surface temperature anomaly in the equatorial Pacific. When it goes in one phase, it stays there for months, right? So because it stays there for months, so whatever impact it has, it persists for a longer time, so we can easily predict that. But if a region is affected by atmospheric variability, it has different challenges because atmospheric variability is more variable in time. So, I mean, a sea surface temperature anomaly may persist for months, but the atmospheric anomaly may not persist for months. So it's difficult to predict. So my point was that if we want to be able to predict these kind of extremes that happen at subseasonal scale, we should have the ability to predict these atmospheric modes of variability, which currently we don't have. So unless we have that ability, we will not be able to improve prediction of extremes at subseasonal scales, like the ones that happen in Pakistan.
Moving on from sort of the predicting aspect, but also building up the capacity to have local data in the South Asian region, what are sort of the issues right now with Pakistan only accessing publicly accessible global data for their weather predictions? And how do you suggest that the region builds up their capacity?
There are multiple challenges that Pakistan is facing, and that which are also contributing to the reasons why the region suffers a lot whenever there is a climate extreme. One, we don't have any educational infrastructure. I can tell you that when I interviewed for that job long back before my PhD, I had zero exposure to climate science. And the reason that our curriculum in early education does not have any climate science as we have in the US. And even today, not a single grad school across the Pakistan provides a comprehensive degree awarding program in Earth and atmospheric science. So that's, I think, the unique situation that Pakistan has across South Asia. Other countries are much better placed, at least in educational infrastructure. So that's one challenge. So when you don't have the educational infrastructure in place, you're not able to develop indigenous leadership. So you don't have indigenous leadership. Secondly, we have one of the poorest observational network in the region. Like Nepal is like 15 times smaller than Pakistan, has like 3 times more observational networks. India has thousands of rain gauge stations. Pakistan, long-term records only 30 to 40 stations, and then even that data is not available publicly. So the issue is that when climate models develop models, they validate their models using station and ground truth observations, right? And if they don't have access to this kind of data, how can they improve models over this region? Most of the models are very unreliable over this region, partly because we don't really fully understand climate characteristics of the region. And then again, the reason is that we don't have good data. So without having good data and without having good educational infrastructure, it's very difficult to build a leadership. And climate science also build the capacity to do forecasting. Forecasting, again, requires a setup because I told you there are models that you need to use. And if you don't have that kind of educational infrastructure, you would not have any ability to develop those models and run those models operationally. And there are other requirements too. They're like you need supercomputing, other resources. So that's why Pakistan 100% its reliance is on the seasonal forecast from the global prediction centers, which actually is not wrong because many countries which are less resourceful, they use seasonal forecasting from these global forecasters. But the other issue in Pakistan is that there's no clear mandate given to any agency currently that who is going to do these kind of forecasts. And they have a meteorological department which should be doing these kind of forecasts and seasonal predictions. But these days you can see there's a National Disaster Management Agency that is dealing with these, which is kind of unusual because NDMA, that's what they call it, is like FEMA in the US. FEMA doesn't do forecasting here. FEMA only operates once there's a natural disaster related with climate or whatever. They operate and try to bring solutions to the suffering communities, right? So, and because of that, I mean, so in my opinion, this lack of infrastructure and everything kind of creates a quagmire that no one knows what to do. So there are multiple challenges that they have. So they need to improve educational infrastructure. They need to have a clear mandate given to one agency and equip that agency so that they can do seasonal forecasts indigenously. And then also they need to have observational network much better than what they have currently, and they should also make it public. I mean, if they want models to do better in that region.
Absolutely. That was actually one of my questions. Do you think that Pakistan should create a more specialized agency just for forecasting like the US And I was also wondering, in terms of building that network, do you think that Pakistan should allocate its own funds towards that, or do you think that it should look towards aid from other countries that are wealthy and high emitting?
Well, again, the thing is, I mean, say you build a hospital, right? You bring a lot of modern machinery, but you don't have technicians, you don't have good doctors to use it, interpret the results is of no use. After some time, it will become useless. It will stop working. That's the same situation. I think Pakistan needs to invest its own resources more into educational infrastructure. They will not get that through foreign aid. And they also have to devise a clear mandate that who is going to do what in the climate domain, right? Any aid agency is not going to tell them what to do. This is what they have to figure out at their own. They have the institutions, it's not like they don't have. They have a meteorological department. And that department has thousands of employees. They have a good network. They have people who can interpret information, climate information from other sources and ingest the local knowledge and expertise and can provide better forecasts. I think there are some steps, these kind of steps they can take at their own. Also, this habit of reliance on aid, foreign aid is also not good. I mean, if you just develop this habit, you will not ever develop your own capacity to stand at your own feet. I mean, you have examples in India. I mean, India also suffers from floods, droughts, and other natural disasters. They, I don't remember in recent past they have ever asked for international aid to deal with their challenges. Pakistan, on the other hand, I mean, whenever they have some sort of calamity related with climate, they just go to foreign aid agencies, which I understand they don't have much resources to deal with that. But I think they need to make efforts to become more self-reliant in this area.
Absolutely. A reliance on foreign aid is really eroding their internal systems and abilities to address their own problems themselves. I really liked your article on the at-risk populations. There's clearly a deeper rooted corruption existing within the country. What are sort of the current issues, both political and societal, with climate justice for at-risk populations, specifically sort of in relation to flooding infrastructure?
One thing, honestly, I can tell you, Pakistan, I don't think they even know which population is at risk because, I mean, they don't have any like developed knowledge about that. One of the major challenges that they have is political instability. What political instability does that it causes governments to make policies which are not sustainable. Every 3 or 4 year government changes, new government comes, brings its own policies, so no one knows what may happen like 5 years down the road. So you don't have any long-term sustainable policies which are needed to develop and establish climate resilient communities. Secondly, as you mentioned, they don't have, Pakistan is one of the countries very, very poor with the justice system. So if you don't have a strong justice systems, there's no accountability, and there's no accountability that leads to corruption. And corruption, if you look at past records, we know that the corruption is deeply rooted, especially whenever there is a foreign aid comes to the country after a disaster. Most of the aid does not reach to the communities. It goes, I don't know where it goes, but it goes somewhere else. And because of that, you get aid in the name of the poor at-risk communities to develop their resilience to climate change, but that does not trickle down. And because of that, it's a vicious cycle that you get an extreme event, people suffer, you get aid goes somewhere else, people still suffer. So people who are below poverty, they stay below poverty. They never have a chance to actually get out of the poverty. I don't know. There's no easy fix for a country which has multi-dimensional problems. So I don't think that they have a clear or an easy solution for these. But I think climate crisis is one of the major crises that they have no clue how to deal with it because of these multidimensional challenges.
Definitely. Thank you for that perspective. To close off, looking forward, what are some of the goals in your career to continue with modeling both empirical and global climate models? And perhaps will that relate to the South Asian or Pakistan region?
there are many goals. One of the goals is to develop like systems that we can use to do better predictions. Like if you can develop modeling and empirical and physical modeling system that can inform about subseasonal extremes well ahead of time, then that may enable governments in the region to prepare and do better disaster planning. So that's one of the goals, and we are continuously doing research, trying to identify different mechanisms, the factors which contribute to extremes, and trying to devise ways that how can we use this knowledge to convert that into a solution system that can be used for better predictions. That's one. Secondly, one of my goals is to develop better climate services, which means that I would like, and we are trying to do that, we would like to make the observational record public, whatever is available, make it public so that it's accessible to scientific communities so that we can improve, validate our models and make better models which are more reliable. I also try to interact with the younger generation, try to see whenever there are opportunities so that we can train them and build the future leadership in the climate science. Other than that, I mean, as I said, we do high resolution regional climate modeling over South Asia. That's one of the regions. And we do have plans for doing our next iteration of high resolution modeling. Pakistan is part of it, and that data is going to hopefully be used in, if you know, there's IPCC report on cities that's going to be available in 2027, 28, and our data is going to be used for in preparation of that report. So South Asia is one of the focus regions for that.
Awesome. Well, those all sound like very impactful goals. Thank you so much for your time.
Okay, thank you very much.
And that is it for the Climate Map today. Please visit theclimatemap.org to learn more about how you can get involved with us.